and 6th graders, welcome to Investigation 8 on displaying data. Some of the information we go over will also be found in Investigation 9. So this whole lesson is on different types of graphs. You're going to be choosing a type of graph to use for your science fair project, so make sure you're paying attention and trying to apply it to that. And we're going to go really quick because we're going to cover a lot of different types of graphs. So there's many ways to display data. You need to choose the best way for your information. The first type is a frequency table. A frequency table shows how often information happens, and it uses tallies to do that. So it's very simple. It's got three parts. It has the data, it has with equal intervals, then it has the tallies, how often it occurs, and then you write the number of tallies in the frequency column. Now, the important thing about a frequency table is equal intervals. There should be the same amount of numbers in each of these spots. So right now I have a problem here. Can you find which one is not the same as the other two? Good, this first one covers 5 numbers. And then here we have 5, 6, 7, 3 numbers, and then 8, 9, 10, 3 numbers. So we need to change this to only cover 3 numbers. So it would have to be 4, 3, 2. This number would have to be a 2, and I would need another one in front of that to be from -1 to 1. Okay, so we've got our tally marks here though. In the frequency table, on the frequency column, you're just gonna write how many tallies there are. So here there's 6 tallies, there's 4 tallies, and there's 8 tallies. Each tally represents one person. So in this case, we had 6 people whose age was between 2 and 4. We had 4 people whose age was between 5 and 7, and 8 people whose age was between 8 and 10. All right, next type, bar graph. You've been seeing these for many years. A bar graph compares quantities with rectangles or bars. They can be horizontal, which means that your bars would come this way, or they can be vertical, which means they would come this way. So you can choose to use either of those types of bar graphs. You also can have a double bar graph, which would have one color bar here and then another color, and then one color bar here and another color to show 2 sets of data. So here we have an example. It says we've got a bar graph that has the ages of the students. We can use this information right here to make that. So let's say down here, we're going to change this again to 2 to make it fair. So between 2 and 4, we've got a frequency of 6. The important thing is our X, our Y axis, we need to go up by equal intervals too, and we need to cover all of the data. So our biggest number is 8. So we need to make sure we go up to at least 8. What if we count by 2s? 2, 4, 6, 8. That works. So we're going to do 2, 4, 6, 8, 10. So that means that for our 2 to 4 range, we had a 6. For our 5 to 7 range, we had a 4. And for our 8 to 10 range, we had an 8. And we would shade it in for our bar graph. Okay? A histogram is the exact same thing, except for we don't have these spaces. So if it was down here, I drew a little example where they're all bumped right into each other. If I was going to make this one into a histogram, and I don't want you to do this on your page, but what it would look like is I would have this come all the way over to here. This would be shaded, and then this would be shaded, and this would need to come to here. So they're all bumping right into each other. That is a histogram. Bar graph has spaces, histogram doesn't. All right, type 4, stem and leaf plot. This has 2 parts to it. The first part over here is the stem. This column right here is the stem. And then this column is the leaf. And our key explains to us what it means. The 1 and then the line with a 2 means 12. So this is basically our tens place, and these are all the ones. So this, if I were to write this data set, the first number is a 10 of a 1 and then a 1, which is 11. This number would be 14. This number would be 16. 16 happens twice. Then 17. then 18. Now we go to the next column. A 2 and a 0 is 20. Then 20 again, 21, 22, 23, and 32, and 34. And there's our data from the stem and leaf. All right, pictograph. A pictograph is just like a bar graph, but it uses pictures or symbols instead of the rectangles. A legend is the key that shows what they mean. So here we got favorite food. We've got pizza and hot dog. So our legend says that one pizza drawing is 4 children chose pizza. And this line means that 4 children chose a hot dog. So I can use this to figure out that there's 1, 2, 3 full pizzas, which means there was 12 children there, and then half a thing, which would be 2. I think that would be half. We're going to say that that's half. So if that's a half of one, then it would be 4, 8, 12, 14. So 14 children would have chosen pizza, and with hot dogs, it would have been 12 children chose hot dogs. Circle graphs. Circle graphs shows the breakdown of a whole number into parts or into percents. All right, so you've got a whole, with the whole pie is 100%. It's the whole thing. And if I said, you know, the pets in our class, how many kids had pets? And maybe we've got, you know, this amount have dogs, and this amount have cats, and this, the rest, we've got, let's see, a little fraction that have no pets. And here we've got people who have birds. So if this was our pie chart all together, all the amount of kids that we have would equal your 100%, and then what percent had dogs, cats, birds, and no pets. And these would be labeled with what percent they are. This is more, a little bit more than half, so that would probably be like 55%. And this dogs one looks like about a quarter, so it'd be 25%. And there's a way to do this that is much more accurate than me just guessing the percents, but that's the general idea of a circle graph. Okay? One more thing I'll say about this. If I told you that there was a total of 20 people surveyed and I wanted to know how many people had dogs, I could say that there's 25% out of 100. And we're going to find an equivalent fraction basically with the total number of dogs being 20, or pets, and then the amount of dogs. We don't know what this is. That's our x. So we're going to say 20 times what is 100 times 5, or 100 divided by 5 is 20. So 25 divided by 5 means that 5 people had dogs. All right, Venn diagrams. Venn diagrams show data that fits into more than one category. So if we had our dogs and our cats, but some people had both. So here, 7 people had dogs, just dogs. 3 people had just cats. And 5 people had both dogs and cats. So that's why they are in the 2 columns together. Okay? If I want to know how many total people were surveyed, I would add up all of these. So 7 plus 3 plus 5 is 15, means that there was 15 total kids asked about their pets. You can use a Venn diagram to show 3 options too. In this case, I got dogs, cats, and birds. 4 have just dogs, 2 have just cats, 2 have just birds. 3 people have birds and cats. See how this spot right here is in both of these circles? So that means they have birds and cats. This 2 means 2 have dogs and cats. 1 has all 3 because it is in all 3 spots. And now our last type of graph that we're going to talk about are line graphs. Line graphs are best for showing change over time. The horizontal axis is your x, and your vertical axis is your y axis, okay? And whenever there's some amount of time elapsing, you always use a line graph. A double line graph compares how 2 things change over time, and we can have a legend to help us figure it out. So here I've got Austin and Philly, and this is their population over, and we've got our years down here. And so for my data, if I was given the population and the year, it said that you're going to look at this when you do the investigation, that there was 700,000 people in 1950. So I did a line right there for Philly. And then there was, in 1960, there was 600,000. So I do a line right there for that. And I made all these points, and then I just connected them with a line to show what happened. And I did the same thing with Austin. So from this graph, which city has increased in population? Good. Austin has increased and Philly has decreased according to this graph. I could extend it based on what's happening and try to estimate what's going to happen in future years if the same trends continue. So this is a double line graph. This is a regular line graph. You've looked at all the other ones. Be thinking about your science fair project, what kind of graph you want to use. Go ahead and get to work.